Hello, drone and geospatial friends. Have you ever wanted to ensure that your aerial photo maps or 3D models are highly accurate, even down to the centimeter? In this comprehensive tutorial, we will thoroughly discuss each step of processing aerial photo data using Agisoft Metashape, with a special focus on the use of ground control points, or GCPs. This is the key to achieving precise geospatial accuracy. GCPs are control points measured in the field with high accuracy using GNSS. We will use this data to anchor our aerial photo model to real-world coordinates. This will be the key to achieving the highest accuracy in our output. You should already have prepared GCP data in the format point name, latitude, longitude, height, or at least latitude, longitude, height, or XYZ in a TXT or CSV file. Agisoft Metashape provides an intuitive yet powerful workflow for photogrammetry. Without further ado, let's begin our journey to create precise maps and models. The first step is to prepare all our data. Ensure that all the aerial photos acquired with pre-marked GCPs in their acquisition and the GCP files are in an easily accessible folder. It is advisable to organize the names of your photo and GCP files. Next, open Agisoft Metashape v2. To start the project, we need to add all the acquired aerial photos. Go to the Workflow menu, navigate to your data storage directory, select all the acquired photos, then click Open. You will see all your photos appear in the Photos panel. If your drone camera recorded GPS information in the photo metadata, you may see some initial coordinates in the reference panel. This will serve as the initial reference before we input the GCPs. The next step is Align Photos. This step is very fundamental, as Agisoft Metashape will identify matching points from two or more photos. This process will form an initial model and determine the relative position of the camera, resulting in a sparse point cloud. In the Align Photos window, you will find several important settings. For high accuracy, it is recommended to use accuracy set to highest or high. Ensure generic pre-selection is enabled to help Agisoft Metashape find relevant photo pairs. Meanwhile, key point limit and tie point limit can be left at their default values or adjusted according to your desired level of detail and computer specifications. Once you are satisfied with the settings, click OK. This process may take time depending on the number and resolution of photos as well as your computer specifications. Once completed, you will see a sparse point cloud in the model view representing the camera positions and general shapes of objects in the field. This is a critical step for accuracy. We will input the GCP coordinates obtained from the GNSS data acquisition results. This aims to provide highly accurate references for the photos, ensuring that the resulting orthophotos and models will have significantly better geospatial accuracy. To do this, go to the Reference tab, click Import, and then select Import Reference. Navigate to your GCP file in TXT or CSV format, then click Open. Ensure that the column settings in the import window are correct. Station for the point name, latitude for latitude, longitude for longitude, and height for elevation. Don't forget to select the coordinate system that matches your GCPs. After that, you will see the GCP list appear in the Reference tab. If your GCP file contains more points than you actually used in the field, for example, only 8 points such as point 2, point 3, FTK, etc., you can select the irrelevant points in the Reference tab and delete them to keep the data clean. Now we will mark the physical locations of the GCPs in the aerial photos. This is a process that requires precision. Select one GCP in the Reference tab. Then, right-click on that GCP and select Filter Photos by Marker. Metashape will display the photos that are likely to contain that GCP. Open at least 3 to 5 different photos showing the GCP. Zoom in carefully and move the GCP marker to the exact center position of the physical GCP object in the field. Repeat this process for each GCP you use. The more photos you accurately mark for each GCP, the better the geometric accuracy you will obtain. After all GCPs are marked, it's time to perform optimized cameras. This step will recalculate and refine the internal and external camera parameters based on GCP data, resulting in smaller errors and higher accuracy. Go to Tools, then select Optimize Cameras. In the Settings window, leave the defaults and click OK. After optimization is complete, return to the Reference tab and note the error column for each GCP. Typically error X, Y, Z, and total. We want these areas to be as small as possible, ideally around 2 centimeters or less. If the errors are still large, you may need to recheck the GCP markings in the photos or increase the number of photos marked for each GCP. If the errors are at a good level, it means the accuracy is considered sufficient, and we're ready to move on to the next step. Alright, with the accuracy locked in by the GCPs, let's build the 3D details. The next step is Build Dense Cloud or Build Point Cloud. This will generate millions of dense and detailed 3D points.
In the Build Dense Cloud, Build Point Cloud window, for good initial quality, we can use Quality, Medium, and Depth Filtering, Mild. These settings are suitable for complex and detailed 3D models, balancing quality and processing time. Click OK and let Metashape process. Once complete, you will have a much more detailed and accurate dense point cloud thanks to GCP. You can pan and zoom to see every detail. The next step is Build Mesh. The dense cloud is just a collection of points, so we need to build a polygonal surface. Go to Workflow, then Build Mesh. In the Build Mesh dialog box, for surface type, we will select Height Field 2.5D. This is the ideal choice because we want to generate a terrain-like surface model which is perfect for creating DEMs and orthophotos. Click OK to begin mesh construction. Once the mesh is formed, it's time to add texture. Go to Workflow, then Build Texture. In the Build Texture window, ensure that source data is set to Images, Mapping mode is set to Generic, and Blending mode is set to Mosaic for smooth texture blending. Then click OK. After this process is complete, your 3D model will appear with realistic and accurate textures in the model view. For most aerial mapping projects, the primary goal is to generate orthomosaic maps and digital elevation models, DEMs. We'll start with DEMs first. Click Workflow, then select Build DEM. In the Build DEM dialog box, for source data, make sure you select Mesh, as it generally produces a smoother DEM. It is very important to select the correct projection or coordinate system that matches your GCPs and project area. Also, set the desired resolution or GSD for your DEM, or at the default if you don't want to complicate things. Click OK. Once completed, you will see the digital elevation model of your survey area accurately georeferenced thanks to the GCPs. Finally, we will create an orthomosaic, a geometrically accurate and distortion-free image map. Click Workflow, then select Build Orthomosaic. In the Build Orthomosaic dialog box, ensure Surface is selected from the DEM we just built. The blending mode Mosaic Default is the best option for a smooth blend. Adjust the projection to match your DEM and set the resolution or GSD you want for the orthomosaic map. Leave the defaults if you don't want to complicate things. Click OK. Congratulations! You now have a high-resolution, highly accurate orthomosaic map ready to use in various GIS software applications or others. Once all main products are complete, it's time to export them for use in other software. To export the DEM file, then export DEM. Make sure to select GeoTIFF. To export the orthomosaic, go to File, then Export Orthomosaic. There, you can choose the format JPEG, TIFF, or PNG according to your needs. GeoTIFF is highly recommended for GIS use. If you also want to export point clouds or 3D models, you can find them under File, then Export Dense Cloud or Export Model. Finally, for comprehensive project documentation, you can create a project report. Go to File, then Generate Report. This report will summarize all processing details, camera parameters, and accuracy statistics, which are very useful for clients or archives. That's it! We have successfully completed the entire workflow for processing aerial photo data in Agisoft Metashape using GCP. From raw photos, we have generated a sparse cloud, point cloud, textured 3D model, DEM, and accurate and highly georeferenced orthomosaic map. If this tutorial was helpful, don't forget to like it, leave your comments below, and subscribe for more drone and geospatial tutorials. Thank you for watching and see you in the next video.